We're going to learn about like scope and what are something known as callbacks in JavaScript, which can be very difficult to wrap your head around. So I'm going to try to break it down like super easy. And this is just basically how JavaScript is written and some of the quirks about it. So the first thing before we even dive into JavaScript in terms of how it does its scoping, let's talk a little bit about Ruby scoping. And that is I have a variable, right, name. Like notice how I don't have to use any of that like var stuff. I can just straight up drop name, which is pretty amazing. And then I can.
Why are you using bar? Like, is it so we understand legacy code, or is it like you were told very explicitly use let and const?
I'm going to go into all the differences between var, let, and const in this lecture. And so I will answer that when we get to that point because there are a lot of nuanced differences. But the short answer, so you have like something satisfactory for you, is that you should understand var, but the movement forward is let and const, and you'll see why. All right. So in terms of like Ruby scoping, here we just have a variable name, and then we have a method called sayName. It simply puts the name, and then I invoke it, right, with or without the bananas. Ruby's just too powerful. Cool. How do I actually run this code? Do I have to put it in the browser? Do I put like a source tag in the HTML? Railscope.rb? Yeah, I just put Ruby, right, because that's the command, and then I give it a file name to run. So if I put scope.rb, what would you expect the same name to put out? Who thinks it's going to be Benny and the Chets? Who thinks there's going to be an error? Who thinks I'm trying to trick you? Very good. Yes. Oh my goodness. Oh my god. It looks like. Whoa. Easy. Yeah. Looks like sayName, right, was trying to be invoked, but there was an undefined local variable or method called name for main object. So, oh my goodness, it looks like I have to pass in some sort of argument in order for it to retrieve this variable. So what I can do is say, hey, there's an argument coming in hot, right? There's an argument. And then I just got to print that argument. So now when I invoke sayName, that argument should in fact be the name variable. So now when I run it, it should say Benny and the Chets. And so the way Ruby scope works is inside these methods, they actually don't have access to anything on like this global.
If name was in all caps, would that work?
No. Simply by putting name in all caps, what I'm declaring is what is known as like a constant variable. But that's not really what we want here. What we want here is this global variable of this $ name. And then I don't need to pass in the argument. I can simply $name right here. And then because it's a global variable, I should be able to run it. Cool? And so the global means that it kind of can exist everywhere outside of what is known as like scoping. What is available to that method at that time? Yeah.
So it's the $sign like the add.
No. What I will say is the @@ is a class variable. The classes have their own scope. But the global means that I should be able to reference this anywhere and everywhere in my application, which is dangerous. And there are a lot of like weird side effects that can happen. All that is to say, let's take a look at how JavaScript runs it. So I can have JavaScript, right? And what I can do is I can write the exact same line of code. And that would be, let's do a one-for-one translation, right? So we can get used to sort of how this is run. So I have this name here, right? So I'm just going to do var name, right, is equal to Benny, and the Chets. Cool. And then I just have a function here. Oh man, say thy name. I feel like this is a Beyonce song, right? Cool. Okay, didn't think that was funny. Very good. And then I simply have to go say thy name. And then is this good enough here? Stop playing. I need the bananas, right? Unbelievable. And then this actually does nothing right now, so I'm simply going to return, or I can console log. Console log, right? That's like the same thing as puts here. And that is going to be the variable name. Notice how I don't pass it in here and I don't really invoke it right here. So let's actually take a look. How can I run this code? Can I just do JavaScript index.js in my terminal? I could use Node, but we're not going to do that. Right now, I just want to teach you front-end web development, but I can. So in the lecture earlier this morning, which you were like very participatory in and very loud in, I mentioned that like in the HTML, you simply have to include the script tag, right? And so the HTML is going to be running your JavaScript because the browser runs your JavaScript, yeah? And so all I have to do is open this file and then look in the dev tools to see like, hey, what's going on with this JS file? So I can simply do that by going open, right, index.html. And open for me right now is defaulting to Chrome, especially when it reads the fact that it's a .html file. Open simply is going to open the file, but it sees the extension HTML and it knows to have Chrome open it. So when I have Chrome open it, loop, right, that's my HTML. If I look at my dev tools, I see Benny. I see Benny in the chats. I can tell you guys enjoy my singing and you want me to quit my day job. Plus, very good. And so let's take a look to see why that might be interesting enough. This looks like, aside from its global variable, like a one-for-one translation. So what we can infer then is the way the JavaScript does its scope lookup is it's going to look from the inside out, always, right? And so it first checks to see, hey, is there a variable defined name inside this function? If not, look outside on the outer scope. And so here, if I were to do something like var name inside here and just go swaggy, right? What should this console log now? Let's find out. Eat. Man, I'm thinking about what the recording sounds like. I sound like I'm like 22. It's very cool. All right, so the idea is that it looks first to see, hey, is there anything defined name? And then it will look outward. So if I get rid of this and I get rid of this, what do you think will actually come up? What the? Oh, God, Chrome is so powerful. It caches it because it's on the global, so it's attached to the window now. Anyways. It should be that the name variable does not exist. Cool? Because I never actually declared it anywhere. But Chrome, yeah. Well, it should be does not exist. Because I never declared it or assigned it a value. Yeah? All right, so that being said, let's just get rid of this. And let's actually go through this powerful README. No, wow, scope. All right, so we have a variable, right? And remember that outer lookup? If I do something like this, the inside scope, right, inside this function declares the name variable, so console log exists as Gary. So far, so good, right? That's just like the 2-second summary. All right, now, there are 3 types of scope within JavaScript, right? And that is what is known as the global, function, and block. So on the global scope, you can think of is anything that's sort of written on this line right here. There's nothing it's nested inside of, right? Whereas inside here, right, between lines 5 and 6, that's inside this function. So far, so good. So we have this function scope here, but anything on this line that's like against sort of like the main code editor should be on the global scale. And that makes sense because the way that JavaScript does it is it always goes from the inside out. And so that means that no matter what you're doing, it will eventually go out so much, no matter how nested you have something, to the outermost scope, which is the outside, so that everything will have access to whatever is written here on this line, on these lines. So that's why it's referred to as like the global. Versus Ruby, where that's not the case, right? Where this is not necessarily the global. Cool? All right, so how much of this, like, do you guys have read and understand, and how much of this is like relatively new. So new, I've read and understand. All right, so we're just gonna fly through this, all right? And just let me know if I'm moving too fast. Cool? This is very important. All right, so the next thing is, right, the function scoping. And it's kind of what we just talked about. Anything defined within a function, right, exists only within a function. There is no outside looking in. So if I have a function, right, where I declare name in here, if I were to say, hey, what is name, all right, what should it be on the global, even though it was defined within the function? Yeah, it's not defined because this is outside. It can never go inside. All right. So the last thing is known as like a block scope. So if something is block scoped, that means that it exists within this block. So a block looks very much like a function, and you've seen common examples. Like, so for example, like between these two, like curly boys, it looks like a block. But the idea is that you have seen blocks before, right? You can have an array. Even in Ruby, right, you have your dot each, and then instead of the do, you can simply put in the pipes, right? Dot each, and then there's like these curly boys, and then you can pipe in like number, and then you can put puts number. So this right here is known as like a block of code, anything that's in between the curly brackets. So you've also seen it in something like this. We have a for loop. This is just simply the condition, and then it will execute a block of code. So something in here is known as like inside the block. So there's three main scopes, right? And so let's actually take a look at this var keyword, right? If I do something like this, and I kind of try to console log it, it doesn't exist, right? The block var is not defined because it was defined inside the block, and you cannot go inside, only the outside lookup. All right. Here we have like just like a regular const. I'm gonna get into var let and const, but I have a block here. Can fly is true, and then if I access pigs.canFly, it's just an object. I'm gonna assign a new variable called hog name. If I try to log it, it does not exist. All right. Let's talk about var let and const because this is going to mean a lot more now. So remember block scoping, all right? So var let and const. There are three different ways to declare a variable in JavaScript. Originally, before ES6, there was only var. Right? So I learned var, and then I had to learn let and const. It wasn't naturally a part of the language as I was sort of like growing up. So here's the deal. If you don't declare anything, right, there's no var let or const here, you're declaring a global variable. So even inside this function, notice how I don't have a var let or const here and I just simply do donut flavor. It will be available outside because I'm declaring and assigning a global variable without the declaration. So var let and const, using those declarative keywords are going to be important so that you don't accidentally overwrite something. Cool? So let's talk about var. var can be assigned and declared as many times as possible. So what that means is I can have a var. Does anyone have like a favorite object? A doggo? Okay. A doggo. All right. And does doggo have a name? Okay, very good. Princess, Fluffy, Acorn. Ooh, Floofy? Fluffy, Acorn, right? Great. Now if I look at doggo, what should I get? Oh, you don't want to say it? Okay. I can just redeclare the variable if I wanted to and simply say var doggo again, and now it's, what? All right, let's put Scooby, but like Scooby, you know what I mean? You like that? With the umlaut? That's powerful. So it's interesting, I can literally redeclare doggo anytime. So if I look at doggo, I see Scooby. Now this code right here can have very weird effects because it doesn't tell you that the variable's already been declared. It just lets you do it. And so naturally, if I'm working on a code base and you're working on a code base, we're all on the same team, and I'm like, man, I love Charles Entertainment Cheese, and you happen to hang out with me a lot, and you're like, oh my God, you know it'd be really funny if I declared a variable called Charles Entertainment Cheese. We're working on the same code base. Now, if we both merge our PRs, we have separately added this variable with the exact same name. We've both declared it. That can be very weird for the program because I'm expecting the variable to be one thing, and you're expecting it to be another, but it could be reassigned and redeclared on the fly. So naturally, there can be some bugs that happen, which is why we're trying to move away from var. So if that's the problem, let's actually solve it. The idea behind let, right, catto, is equal to meowfie, right? It's TM. Oops. Oh yeah. Cool. Meowfie TM, right? The idea is that I should not be able to redeclare the variable. So if I were to do something like let catto equal to something else. Okay, pants. Let's just put pants. It's a lot to write right now. It gives me this error. It says the identifier catto, the variable catto, has already been declared, which is interesting. But let me actually try reassigning it, right? So if I say catto equals to hello kitty. Interesting. So if I look at catto, it allows me to reassign, but I cannot redeclare. Are there any questions between the difference of var and let? All right, who feels good about it? Sure.
There's a difference between declaring and assigning.
Yes.
Could you briefly go into that just so I can stop it?
Sure. If I'm declaring a variable, I'm using one of these declarative keywords like var, let, or const. If I'm simply reassigning, I'm taking the variable and saying you are now this value, as opposed to saying I'm making a new variable, I'm declaring it to say, hey, I'm making a new variable called cat. Like if I were to do let again and put catto and not actually assign it anything, I'm attempting to declare the variable. I can declare and assign in the same line, but they are different operations.
Okay, so what happens if you set something that is a global object or a global variable first? Like if you did like birdo equals bird.
Okay, so you want me to do that right now? Okay, let birdo equal to bird. Very good. Oh, no let?
Yeah,
You want a var or?
no, just in general. Like, yeah, there you go.
Okay.
So if you try to do let birdo after you do that, like it can.
You mean like this?
Oh, yeah.
There should be different things now. So this is attaching itself to the window object, which is a little bit different. And this is declaring a variable.
So when you call birdo, like, how does it know which one to look at? Oh.
So there's something called the global object, so window. And this is everything that the browser can possibly do. So if we look at the window object, it gives you everything like alert. You ever seen alert?
Yeah.
Right? So like if you do like alert, and then it goes, oh man, tricked you. And then it does that. That's because the browser gives you that functionality. So what Birdo will do without any declaration is I'm attaching this key to the window object. It's the same as doing like window.birdo. Versus when I do let Birdo, for the first time, I'm declaring its own variable.
So I think I get it.
Yeah, so now if I try doing it, it's
Yeah.
like it's already been declared.
Well, is that the situation when it would make sense to just declare a variable but not assign it?
That actually is a very good question. The question is, when would you want to declare a variable but not assign it anything? When we get to asynchronous functions on Thursday, you'll see why that might be important. The idea is that I want a variable to exist and then assign it a value later so that I have reference to it. Like I don't know what the value is going to be. So for example, if I want to make an API call, and let's say I'm building an application that determines if it's sunny, I want a burrito, and if it's rainy, I want some ramen, I want some soup, right? The first thing is I'm going to have a variable called food. I'm going to just put let food and then nothing. I'm going to make an API call to weather.com, and it's going to pull the data. And that way, when I look at the data and it's like, yo, it's sunny today, I can then reassign food to be like burrito. Because if I use let at that time, remember, if I make the request and then I use let food equal to burrito, and I try to use burrito later in another function, because of what we learned just about scoping, if I use let burrito at that time, it's scoped to that function, and I can't use it outside that function ever. But if I put it on the global, then assign it information inside the function, I still have access to it outside the function. Does that example make sense? So like, let's just do it. Ready? So I can put let food and nothing. I can go make an API call, right, that gets the weather. Right, so it's a function, get weather, get, I was gonna put wet, but that's not gonna work, weather. Yeah, I don't know, I'm gonna get in trouble. So then in here, it's just gonna return, I don't know, SUNY, right, that's SUNY. So then I'm just gonna put if, right, here we go, get weather, right, if get weather, boop, boop, is equal to sunny, then I'm gonna assign food to be burrito. Notice how this exists on the global. Then it's food assigned here, reassigned here. It's just declared here and then assigned here. If I wanted to use food right here on this line, right, like if food equals to burrito, right, boop, boop, boop. Sorry, this is a, right? Then like do cool stuff, right? Powerful right here. There's some logic here. The idea is that if I do not do this, I have to do it here. And the problem with that is that now this let is trapped in the block scope and I can't use it here. So if I simply declare it and then assign it a value later, I have access to it on the global. This might be a really good reason for it. Is that like clear to people? Yeah? All right. Send it.
So where is this, you said earlier that JavaScript reads from the inside out.
Yes, from the inside out.
So could you walk us through what it's reading here first in terms of inside out? If that makes sense.
Great. So what it's going to do is it's going to read. It's going to say, oh, hey, let food, currently undefined. I'm going to make some weather API call. It's just going to say, hey, it's sunny. Good deal. Now when I invoke weather, it's going to return sunny. And if that's the case, then it's going to tell me food is now burrito. So then now I can say, hey, if food is burrito, go do something. And it reads top to bottom, left to right, very much like Ruby does. There's some nuances later that we'll get into, but.
Where is the inside out?
So right now this is on the global, right? If I were to do it here, because remember, food doesn't exist. I don't want to do this because it attaches food to the window object. I would have to declare and assign it. Now, we just learned about function and block scoping. Do I have access to food outside this block? I don't. So this would break always. If I declare it outside the block, reassign it, I can use it because this was declared on the global. Yeah? Powerful. Powerful stuff. Any other questions? That was good. All right, so, oops, poopsie daisy. All right, so var can be reassigned and redeclared as many times as we want, whereas let can only be reassigned as many times as we want. We just saw like a somewhat practical use case for it. And now we have something called const, right? Const is just short for constants, and they mean that you cannot redeclare or reassign. Once I set it, you gotta forget it. Cool. You can mutate the data, thank you. Thank you. You've seen that commercial a long time ago? Just set it and forget it. Very good. Once you declare the variable, you cannot change it anymore. So, for example, if I were to do const, you have another animal that you want to just slap a O to?
Squirrel.
Sure. Squirrelo, right? If I do const squirrelo and I do not give it a value, what do you think will happen?
Weird. It will be undefined for the rest of its sad life.
Yes, it'll be undefined for the rest of its sad life, right? Very good. Direct translation. The problem is this. Do you ever want anything to be undefined for the rest of its life? Come on now. It's a little bit smarter than that, and it straight up tells you, hey, missing initializer in the const declaration. You're not giving it any real value. Because you can never reassign it, you have to assign the value when you first declare it. So if I do const, do you have any other animals? Goto, right? Look at this. I think there's a goat in here. Powerful, powerful. That makes sense, right? So now I could look at Goto. But if I ever go, yo, Goto, you are now, I don't know. What was that other one? Sheep? Ah, that's not right. It'll be like, whoop, you've already assigned it to a constant variable. You cannot reassign it. Cool? So, feeling so good? Difference between var, let, and const. Var can be assigned and declared as many times as you want. Let, you can declare once and reassign a million times. With const, it's only one declaration, one assignment.
There are some weird things about const.
We're talking about reassignment. So if I do const, right, your boy, is equal to an object, and if I took a look at your boy, it's just an empty object, I can mutate the data, but it doesn't mean that I'm actually reassigning it. So if I wanted to add a key of shit, right, and the word is of Mystical, a popular rapper, ch. He doesn't say yeah, he says ch. I can. I've mutated the data, but I have not reassigned it. Does that make sense? I've changed it, but I didn't say you are now this. I'm saying like, hey, I'm just going to add this to it. In the same way that if I push something into an array, I'm simply adding to the data that exists. I'm not saying that this array is now equal to an array of 1, which would be a reassignment. But if I do dot push 1, then I'm like adding onto something that exists already. So mutation and reassignment are different.
Is there like, I feel like there's something where you can like temporarily reassign it, but then like, I could be wrong, but then if you like reference the like, I don't know, go again, then it would like go back to the same value that it first was, or never mind, I think.
No, just remember mutation and assignment are different. So const says you cannot reassign, but you can mutate the data. All right, so far so good. We're just going to move on. All right, great. So there's something very interesting, right? And we're going to dig deeper into like why var is kind of wacky. Something called hoisting. Have you read about hoisting? Okay, great. What is hoisting? It can be. It can be.
It's when a declaration is raised to the top of the block where it exists, a variable declaration, so that you can access the variable from anywhere in the block, even if you define it low down in the block.
Close, very, very close. The idea is that you can reference a variable before it is actually declared. That is like what I would want you to take away from it. So I'm going to read you the technical definition. I'm going to break it all down, and then I'm going to show you an example so that it makes sense to you. Because hoisting is 100% a JavaScript interview question. They will be like, hey, what's hoisting? I mean, yeah. So, ready? This is the MDN definition. Ready? Because variable declarations, right, declarations in general, are processed before any code is executed, declaring a variable anywhere in the code is equivalent to declaring it at the top. This means that a variable can appear to be used before it is declared. So let's break that down. When I'm in my JavaScript, I want to explain something that's pretty important. And that is, if I use something like var, right? Var happy is equal to, I think there's like, I like this cowboy. Powerful, right? I sent out this video, like JavaScript, the weird part's like 3.5 hours. Please, when you get a chance, sometime today and tomorrow, try to get through it at like 1.5, 2 times speed. What it will explain is how your JavaScript is running, and it will run in 2 phases. The first phase is what is known as a read-through phase, and the second phase is an execution phase. So the first read-through will essentially read through all your code. It won't do anything with it. The second time it runs through, it will actually execute. So let's demonstrate. If I were to console log happy, let's see what actually happens. If I refresh, I get this cowboy. So far, so good, right? What happens when I do this? When I console log happy, before it is declared? Who says the happy cowboy emoji will come out? Who thinks it will be undefined? Who thinks it will break and say that you've never declared it does not exist? Let's take a look. Bloop. It's undefined. So let's actually do this. Bloop, bloop, bloop. I should see undefined and then happy. Here's what's actually happening. In the first read-through, right, take a look at console log. Ready? There's a difference between line 8 and line 9. And what is line 9 in terms of the function? Is it being declared? Is it being invoked or not? It is not. So that means that on lines 8, 11, and 12, what's happening is JavaScript's going to read through your code top to bottom, left to right, and assign things to memory. So it's going to read line 8, and it's going to go, oh, a console log, that's being invoked. I'm going to let the execution phase take care of that, and it will skip over it. It will read line 11 and see, oh, var happy is equal to this cowboy. But as we know, var can be redeclared and reassigned as often as possible. So does it make sense for the compiler to save in memory what it's actually assigned right now, knowing full well that on line 20, I can probably have another var happy equal something else? It doesn't make any sense. It's just going to go, oh, great, you've declared a variable happy. Cool. I'm not going to waste my time storing the data, because right now it's just an emoji. But it could be an object with like 20,000 lines if I wanted it to be. So it doesn't make sense to store the value. It's just going to go, great, you've declared a variable. That's all I need to know. Say less spam. And then it's going to keep going. So it saves happy as a declaration in memory. And then it goes to line 12. It goes, oh, look, another log that's being invoked. I'm going to let the execution phase handle that. It's going to go all the way down to line like 200, and it's going to go, cool, done. It's going to come back. It's going to go 1, 2, 3, 4, 5, 6, 7, 8. Now I'm in the execution phase, right? Part 2. Log is being invoked, which is part of the execution phase. So then it will execute that log. At that time, does happy exist in memory? Yes, happy exists in memory as a variable, but remember, it did not store the value. It just says that happy exists. So naturally, if I'm trying to log it, happy exists, but it has no value, so it comes out as undefined. When it hits line 11 in the execution phase, it's like, great, I'm actually executing. Let me actually assign the value. So now happy, which already exists in memory, now has a value of this cowboy. So when I hit line 12 and I log it again, it now has that value. So there's the 2 read-throughs of JavaScript that's very important to understand why hoisting is happening.
If you use let or constant instead of know what it is.
Now, remember the logic for var, which can be reassigned and redeclared as often as we want. What about let? Can I redeclare let as often as I want? No, I could just declare it one time. So when the compiler is reading through, it's saying, oh my God, look, let happy. I'm going to read this at this point and go, great, I have a variable happy and I'm going to assign it at this time. So if I go back, it cannot access happy before it is initialized. So this log will break it. So what we can determine is that var will hoist. You can use the variable before it is declared. Even though it comes up as undefined, it still exists. Whereas let and const do not hoist. You cannot use let and const before it is declared. And it's simply because let and const don't let you redeclare. So it doesn't make sense for the compiler to think through like, oh man, I can reassign this anytime I want. Does that make sense?
Oh, where would it be useful? It's not storing any value.
If it's not storing any value?
Because it doesn't know what happy is. So how can we use happy before it's initialized?
Right, the idea is that people would sometimes utilize their code before they're declared. This is not actually very practical, which is why let and const came out. But this is the phenomenon called hoisting because var is a legacy and var is like ES5 and all that. You can't actually change the functionality of var because you'll break so many things that existed and relied on it. So var is here to stay. We just use let and const now for the most part because you can already see how var can possibly be a little buggy and like hoisting.
Yeah, the lab told us never to use var.
Okay.
It literally said never use var.
Okay. There is a time and place for var. But for your purposes here in the schoolhouse, you will basically never run into an issue where you might need it. But the idea is that var hoists, let and const do not, and var is not block scoped, and I'm going to go over that in a second.
Sorry, so during the first phase, like the reading phase, is it reading var happy first, or is it reading console log?
It's going to read console log, but console log is being executed. It's being invoked. So in the read-through phase, it's going to be like, oh, this is something for the execution phase, and it will just skip over it.
Okay, that makes sense.
Yeah? Question?
So, if var is not used much, then we won't actually be like doing that much with it.
You won't write var hardly ever, but var is very important, and I'll get to why at the end. Yeah? Okay, so far var hoists, right? Another weird thing about var is not block scoped. So let's take an example here. Boop, boop, boop. We have a for loop, right? We just have a var I, boop, 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 and then it simply is just going to console log I. Cool? And then instead of array.length, we're going to do an actual array of 4 things. And I'm just going to copy this code. So look what happens. 1, 2, 3, right? Because the for loop ran. So far, so good. So what is I right now? If we take a look at this code, what should I be?
In the outer scope, probably main error.
Like if I tried to console log I, and I put multiple arguments to console log, like boop, 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 this is I. Let's take a look. It knows, which is bizarre. Why should I escape the block? Once I do a for loop, I want that self-contained. So let's take a look. What if I did, right, and not var, but let. And I can't use I, obviously. So let me use j for funsies. I'm going to do all this with the j++, and then I'm going to console log j. Whoops, just j. Okay, see, same thing. So what is the value of j? J is not defined. So in the first example, we had a for loop with var. And now I is 4. That means that var left the block. var is not block scoped. Because when I use the let, and then I asked for what j is, it said it's not defined. But when I had the var for I, it's now 4. So I actually don't want anything to happen outside my for loop. So var is not block scoped, it hoists, and it can be reassigned and redeclared a million times, or a billion, billions and billions and billions and billions. So those are the main reasons why var is sort of a way of the past. Any questions about var? Var?
Or just, what the code is making it at like the 4th time or trying to
Okay, so let's go over the for loop of what's happening. var is, I is 0, right? And it's going to go through this, which is the length is 4. As long as I is less than 4, right? So then the condition is that when you're done with the for loop, I++. It's going to log, which is 0. Then I++, so now it's 1. Is 1 less than 4? Eats for cheats. Log again, I++. 2 less than 4. Log, plus plus, 3 less than 4. Log, plus plus. Is 4 less than 4? No, but what is I now? Yes, that's the condition. Is 4 less than 4? False, and then this for loop ends. So I is technically 4 at this point. So it will increment one more time and check and test this right here. And it runs false on this condition, so it does not continue.
How does var not be block scope not, or doesn't that contradict the idea that JavaScript reads from the inside out? So does it just not apply to var?
This is the exception to var, that it's not block scoped. It is function scoped though, which is why the function block and global scopes are different. Yeah? All right. That's tough.
So if you put that, the for loop in a function,
Yeah.
and then try to call it outside of that, it would show something.
It would not work because it's function scoped. Yeah. So, hoisting. Hoisting also works for the function keyword. So, for example, if I was in here, right, and I'm just going to get rid of all this, bloop, and I simply try to console log, right, this is my fun function, and I'm just going to say function keyword, fun function, boop, 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 and it returns nothing. Cool. The idea is that fun function is before line 23. Let's actually see what happens. It exists. So the function keyword is a little bit different. In the read-through, most times people do not write somewhere else in their code function, fun function again. They do not redeclare the same function. But the function keyword hoists, meaning I can use it and it appears to exist before it is declared. So far, so good? So because this phenomenon doesn't happen, in the read-through, it will actually store the entire function into memory, versus the var keyword, where it'll just be like, cool, I see the var, I don't really care what's after it. Cool? Yes, no? Oh, yes, 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 yeet. All right. All right, so that's hoisting. Ready? Variable declarations are processed before any code is executed. So there's the two phases of execution, the read-through, then the execution phase. Declaring a variable anywhere in the code is equivalent as declaring it at the top because it finishes the read-through, and then in the execution, it actually has access to that in memory on line 1 on the execution. This means that a variable can appear to be used before it is declared. Does that make sense now? Or more sense than it did? Or the same? As long as it makes sense. All right. Great. So, var, you guys feel good between the difference between var, let, and const and why we Are moving more toward let and const? All right, that's like a big takeaway. All right. Yep, cool. All right. Do you guys want to break or do you guys want to power through? Break? All right, cool. Let's take a 5-minute break. If I use const there, would this, exactly, it would break.
J wouldn't change.
Because J cannot be reassigned, right? So for the for loop, let is the move. Yeah? So that's kind of like the one thing where you start to notice the difference, and then you can start to pick the correct one. If you're never going to change, you should be using const. If you feel like it might or may change, typically with numbers or something, you're going to use let. That's kind of the main like rule of thumb. Yep. Yeah. You eating? Attaboy. All right. Sorry, I didn't mean to blow you up. All right. Great. Let's talk about functions. So I'm going to read this definition. All right. It's a lot of technical terms. It's kind of boring, but I want to be able to like break it down for you. A programming language is said to have first-class functions when functions in that language are treated like any other variable. That doesn't really mean much right now, but let's actually break this down. I can have a function and assign it to a variable because what are functions in JavaScript? They're just objects, right? So the same way that I can do like var, like food, is equal to an object, I can also do var food is equal to a function. And that function just returns yeet me. Nah, I don't want to do that. Yeet this hall. I don't know what that means, but my friend said it, and I thought it was hilarious. Actually, Andrew said it. It's like, yo, let's yeet this hall. I was like, okay. So if I look at food, I see that it's just a function. I can even, if it's a function, I can even invoke it. So a first-class function or first-class programming language just means that functions are just objects. Cool? This becomes very dicey very soon. So any questions on functions are just objects, you can store them in variables. All right, let's go. Okay, cool. Huh?
So you have like var say hi there. The function isn't saying hi, that's just it's stored in the variable say hi.
Correct.
But then wouldn't you need to name the function?
Well, I don't have to name this function because there is a reference to it, because I have the variable. Yeah?
So would you normally not name the function if it's stored in a variable?
Correct. If I'm storing it into a variable, I normally will not name this function. Later on, much later on, you will see a difference between this and say hi here. You will see a difference between this var and it being an anonymous function and just the function say hi. You'll see a difference later.
Isn't a possible difference have to do with wasting this functions? The whole thing is wasted.
Correct. Remember var hoists, right? And the function keyword hoists. What if I did, oh, I don't know, bloop, would say hi now hoist? Nah, dog. It does not. It does nay. It doesn't. Okay? For those that didn't speak my nonsense. All right? Cool. Great. So here's the deal. If functions are just objects that can be stored in variables, let's think of something else. Let's talk about callbacks. Here we go. I can have, it's going to be tough. Actually, let me write it in JavaScript. All right, here we go. Ready? I can have, right, an object, right? Const object, right, is equal to regular old object. A plain old JavaScript object. Don't say that. You could say that. I'm not going to say that. Right? And I can have const, right, function object. Remember, it's just return and then a little action there, like that. So far, so good. I can have function, function 1. So far, so good. And I can simply console log OK. So far, so good, right? I have just an object, and then I have a function object that's just holding a function. That's it. Just 2 variables, nothing wild. Let's do this really quick. Thought experiment. If I were to pass in an argument to function 1, right, like an argument, and then I do fun1, and I drop the bananas, am I invoking it or no? What about now? No. That's right. Now I am not. Yes? No. Yes? No. Yes. I'm just being stupid. So the idea here is I can pass in an argument, right? I can just pass in a string that says yes, me is argument. What will happen in function 1 with this argument? Nothing, right? I'm just passing an argument, but I'm not using it here. So far, so good. So what is the result of function 1? A console log of OK. But now I want to actually use the argument. What would be the result of invoking function 1? Okay, let's find out. Oh, there it is. So far, so good. Now, let's get one step further, one level of abstraction. Yeah.
If you didn't pass in any argument, what would happen?
You're talking about invoking it with no args? Because it's looking for an argument. It's not getting anything. So arg exists as a variable, but it has no value. So it's undefined. Now, I pass it in as a string. What if I pass it in object? What will this console log? Let me just put in Chuck E. Cheese. All right, and I passed in object here. What should fun1 console log? The object, right? Bloop. So far, so good. Nothing crazy. What's the difference between passing in the object and just passing it in this function object? Ooh, snap. What will this log? It should log whatever this is assigned to. In the same way that when it logged object, it logged the object. If it logs this, it would make sense that this whole thing is logged. So let's take a look. Bloop. And it does. It logs the entire function. So what does this function return? What does this function return? Ye, right? So if this argument right here is actually a function, and this right here is a function, it's a function right here, yes? Can I invoke it? Yeah, so let me go, bloop, I invoke that function. So what should function 1 be? Because remember, this right here is not invoked, it's just the function definition. This is it being invoked. So this right here is actually a function object, which is this, which when invoked returns this ye. So if I'm going to log the return value, I should just get this string. So far, so good. I'm going to get to your question. Let me just finish this whole thought. So that means that function 1 gets a reference to this function. Because inside function 1, that function will be invoked. One more time. I need you to follow me. I'm serious. Inside function 1, it receives a reference to this function. I am not invoking it here. I'm passing it as a reference. which means that this whole function gets passed in as an argument. If the whole function gets passed in as an argument, I can invoke it inside this function. Are there any questions on that alone? Now let's take it to the next step. If I do not pass it the reference, and I invoke it right here, what actually gets passed into function 1? The string ye, right? If the string ye gets passed in, can I invoke the string? No. So I would see arg is not a function. I cannot invoke it right here because I invoked it here and the return value is a string. So when you're talking about callbacks, you must pass the reference to the function. Are there any questions on that? Callbacks need a reference because in the original function, that's what's going to do the invoking. You had a question first.
So can you explain one more time, like, when you get console.log and you pass in arg, but you don't invoke it, it just gives you
It will,
thing within the like squiggly lines of the function.
if I do not invoke it, remember I pass in this function, right? It goes literally right here. I'm just logging this function. I'm going to log the reference to the function. Yeah?
So it automatically like, never mind.
Yeah?
Sorry, your callback function, because I'm just having trouble describing what it is. It's just kind of like a function that's called in another function.
That's exactly correct. A callback function is a function that gets invoked by another function. So that's exactly where I'm walking you to, right? Function 1 receives this callback, and function 1 is the one that actually does the invoking. Oops. Function 1 is the one that actually invokes it. Yeah? Let's see a more practical example. Who has done the .each already? Like the iterators on JavaScript. Not the for loops, the enumerables like for each and map. All right, they require what is known as a callback. So let's actually try to break that down. So I have an array, right? So I can do let or const. Let's just do let. Cool array is equal to, let's just put some cool people. What? What?
Me.
Me?
Me. Yeah, me.
All right, me, right? And my favorite friend, Swaglord, and naturally, Benny and the Chets. Cool? So I can do the cool array, and I can call in, all right, like map. And map is just an enumerable, but it doesn't really do anything. What map is looking for is map is looking for right here a callback function. So far, so good. So what that means is I can do one of two things. I can either write the function right inside, in line, or I can do function, right? Pass this into map. And this is a function that simply does returns e. Right? This is a function, right? I'm going to pass into map, right? It's just a callback. There's no difference between a regular function and a callback. It's just how it's used. So I can do something like, in the map is a one-for-one transformation. So what do I want everything in this array to become? I can inline it. So it needs a callback. So I have function here. And I'm simply going to return, right, all your base are belong to us, right? Now, if I look at this, is map being invoked, yes or no? Is map being invoked, yes or no? Let's take a look really quick. Ready? Is the map being invoked, yes or no? Okay, it's definitely being invoked. And this is the callback function I'm passing it. I've just wrote it in line. Let's take a look. Okay. It doesn't really do anything. This is going to be a const, and that's going to be new array is equal to this map, right? So now I should just console log the new array. Sorry about that. Great. It's all your base belong to us, all your base belong to us, all your base belong to us, which makes sense because map is a one-for-one transformation. I'm taking something and just making it into something else. So far, so good.
Just had two questions. First one is, would you say it's more common to write the function inline or reference a function directly?
It depends on what you're doing.
Okay.
It is more common to write a function to reference. And I will explain why. It's very complicated. It's not really complicated. I'll explain why.
Will you, in this lecture, be showing us how to do like arrow syntax with functions and arrow notation?
I wasn't planning on it, but I could show you. It takes 2 seconds.
Okay.
Yeah? If I forget at the end, just remind me. Just be like, Evans, you forgot the arrow, you dirtbag. I'm like, okay, great. No need for name call.
Is map used exclusively with bot?
All the enumerables will receive a callback, yes, which is why I want to explain how this callback is working. So, remember, map, right, it's just going to return this. So, inside map, as you know for Ruby, it takes a block. And that is, I have to define one of the things. So, in Ruby, it would be coolarray.map, and then I would have a block of code. And this thing right here is like peeps, right? Or peep. And then you do peep, I don't know, +1, or whatever. Like you do some block of code here, right? So, I can identify a variable. Where is that variable here? How can this block of code, this function, receive some sort of argument to be each one of the things it needs to iterate over? Where do you think that might be a good idea to possibly place? Right, so it gets each thing here, which makes sense, right? It's going to receive each one of the items to iterate over. So if I want to do that, I can simply return, and remember those backticks, too powerful. Money each, that was kind of aggressive, I'm sorry. Right, each thing here plus new string. Cool? Oops, just kidding. New string. It's already string interpolated. If I refresh, oops, am I in JavaScript hell? Oh, right. I forgot. This Ruby is not good. Me plus new string, Swaglord plus new string, Benny and the Chets new string. So each one of these things go inside this callback. Now, I said there was 2 options, right? I said I could do this, or I can pass it a reference. So what I can do is, let's pass map, and let's just do this exact line of code. So now pass this into map, and this callback function are exactly the same. Yes or no? What's it missing? Right, it's missing. This pass into map needs to get some sort of argument, right? So each, bloop, embarrassing. So each thing here, this is going to receive an argument. So what I can do, instead of writing it inline, I could pass it a reference to a function that does the exact same thing. That's the refactor.
So you're basically calling past things into map in
So here's the thing. Pass this into map is not being invoked here. That's the trick. It's not being invoked here because somewhere in the map function, this callback will be invoked in the exact same way that when I did fun1, so fun1 is map, right? I'm passing it a reference to a function that is not being invoked because somewhere in the map source code, the callback will get invoked. So this right here and this right here are going to be the same because this function, right, is not being invoked. I'm simply declaring it inline, or I can pass it the exact same functionality. Yeah. No, it's totally fine. This is very difficult to understand.
So you don't have to put like the argument each thing here because it's assumed that each thing here is an element of that way.
Correct.
Okay.
Right. How are we feeling? All right, this is very, very difficult to grasp. So if you understand it, but you just need practice, that's where I need you to be. That the callback is a reference that will get invoked.
So checkpoint 44.
Oh, the double? Thank you. Embarrassing. Cool. All right, so I'm gonna get rid of this, otherwise it'll error out because the cons can't. You build your own iterators. So like build your own for each. But the labs will help you do that. So go through the labs. That will be the practice that you need. All right? So let's continue. Great. Boop, boop, boop. Now look at that. It's tricky stuff, right? Now, functions can return another function. So I can take an outer function, and that's simply going to return another function. So if I invoke outer function, what do I get back? What is the return value of outer function? Yes, an inner function definition. An inner function definition is in fact a function. So I can invoke that as well. So this should not look too crazy to you. Right? If I invoke outer function, I get back a function, which can then be invoked. Yeah? Yeah, it's bizarre. Okay, so far so good. JavaScript's wild. It's the Wild West out here. All right. So, huh? You wanna take a look at this or? Okay. Jinkies. Oh my god. Okay, yeets for cheats. All right, so I want to talk about this closure, and then I want to talk about how we can use functions that return functions as sort of like a fun, practical way, right? So the idea is this. This is what a closure is. A closure is a combination of a function and the lexical environment within which that function was declared. This is what that means. Lexical, you play, not Scrabble. What is that other one? It's like a dice, and then you like mold clay. You know what I'm talking about? Cranium. Oh, thank you. All right, you ever like lexicon or whatever? Anyways, the word lexi is just referencing like word. Like the word. Word. Okay, y'all didn't like that. Very good. But the idea is lexicon just means word, right? So what is the word environment? Plus the function. So this closure right here is this whole thing inside of the function closure. So the lexical environment is this variable cheese and this function. Because when I look at this function, I see a reference to cheese. But cheese was not defined within this function. So far, so good. So the closure is everything in here. The lexical environment plus the function. Here's why closures are tricky. Because if I copy and paste this, right, and I invoke closure, right? Let's take a look at closure. If I invoke it, what do I get back? I get another function, right? And in here, it says, I like to eat cheese. But where is cheese declared in here? So what if I did this? What would happen? I like to eat cheddar. So if I did something like a var, right, wow, equals to closure that's invoked, what is the value of wow? But cheese is not defined anywhere. So what that means is the closure had saved the variable in memory when I invoked it into wow, so that it's not only the function, but it also has that memory of var cheese. So if wow is just a function, I can invoke wow and I see cheddar. Sophia's boyfriend, huh?
So that's,
That was out of left field.
so that's the same, like, invoking closure and then invoking wow is the same as invoking closure.
Twice, correct.
So is there any way to see besides invoking, like, if you just wanted to see, like, what the variable was inside closure, is there, like, any way?
There's no way to see it.
Yeah.
It's the way to create a private variable, which is why closure is so important to understand.
Yeah.
Cool? All right, so let's go over this last thing, and I promise I'll let your brain rest for a bit. All right? Okay? Yo, I heard you like JavaScript, so I put callbacks in your callback so you could call back while you call back. Very good. Thank you, Exhibit. So let's actually see what kind of like use for this is. All right? If I have a function called multiply by n and it takes an outer number, it simply returns another function that also takes in its own argument. And leveraging the power of closure, I have outer num and I have n. So if I make a new variable called multiply by 10 and I do multiply by n, what is the return value of multiply by n with a 10? What is the return value of this? That takes what? It takes an argument of n. So that would mean that if I stored 10 in here, outer num is saved inside this variable. And then if I invoke multiply by 10, remember, multiply by n returns a function. That means that this is in fact a function. So I can invoke it, and it takes its own argument. So multiply by 10 is storing outer number, which was 10, in it. And then if I invoke that with 5, it's doing 10 times 5, which is 50. So by having one outer function, I can create multiple functions, multiply by 10, by 5, by 2, by using this same outer function multiple times by simply changing its arguments. You can see the difficulty and the power of JavaScript scaling very quickly. I feel like that Zac Efron meme. You know what I'm talking about? The Zac Efron meme? Zac Efron, and he's like confused or something. And he's like, hey. All right, sorry. Okay, great. So this function returns a function. So this is the function that needs one more argument. And there I'm providing it. All right, I'm going to move on, but if you have questions, I'll be happy to follow up after lecture, which is going to end in like 2 minutes, all right? Science. Actually, that was really the end of it. The last thing I want to say is this outer function that returns this one is known as like a higher order function. And it's simply because this one must be invoked first before this one is even like really available. Cool? The higher order function is, there's a definition. Yeah, great. It takes one or more arguments, one or more functions as arguments, or returns a function as a result. That's just the definition of a higher order function. Cool? All right. Are there any specific questions, or I'll let you, yeah.
Arrow functions.
Thank you for that. Powerful. You dummy. All right, cool. Let's do this. There's an entire lecture on arrow functions, but I'm just going to go over the syntax. So I have a function keyword, right? Me, boop, boop. Or I can have an arrow function, right? And that is simply going to be like const me is equal to the arguments with this arrow syntax like this. So you can have the function keyword, or you can have the arrow. That's kind of the main difference that you need to know right now. It gets very dicey later on, but this is the syntactical difference. Cool? So if I wanted to put an argument in here, I can put anything and anything too. Then I would put as arguments here anything and anything too. Cool? I will tell you, just understand that whenever you see this, it just means function. I will go next week into like a very lengthy detail about what the arrow function does and its nuances, but for right now, whatever you're doing, they're essentially equivalent for like all the labs and stuff for right now. Cool? So you have the function keyword, or you have the arrow syntax, and that's really the main difference. All right? Cool. All right, that's all I have for you guys today.